Hi, welcome to the Ben and Chris show. I'm Chris, and this is Ben. Today we're going to be talking all about data analysis in Python. Now we've been building on this for a few weeks now. So episode 7. So this is 7 weeks that we've been promising people that we're eventually going to get some data analysis. And last week we got to the position where we could read in files and kind of iterate for arrays. Today, data analysis. So do you want to get us started, Ben?
Yeah, sure. So that's what we're doing today, right? So kind of what we've been doing, and all these weeks you've probably been going, hang on, this is all about data analysis. Where's the data analysis? The idea is that these weeks of we've been teaching you the tools to get started in data analysis. So now we're actually going to look into how to do this stuff. So we've learned all about Python, and today we're going to put it into use. So we're going to have a look at just some basic data, and I'll get into that in a minute. But if anything here is confusing and stuff, it might be worth checking out the previous weeks. So if you come across a for loop and you've never heard of a for loop, we have covered that in previous weeks. So just be aware of that. So yeah, today that's what we're going to do. We're going to have a look at how to analyze some data. So read in stuff from a file like we did last time. We're going to have a look at parsing that data. We'll get onto what parsing means. And we'll also have a look at some really cool functions that we can use in Python to analyze this. So I'm going to talk about some ways of analyzing this data, but I'm also going to show you some really useful functions that come with Python. And I think this is where Python is really useful, because there is absolutely thousands of libraries out there that people have made in Python for you to use. So a lot of the stuff that you want to do in Python is just there already. So for example, if I wanted to run a Ttest, there's a library there, and some guy has made a function somewhere that does that for me, so I don't have to reinvent the wheel. So yeah, on that note, if you look at the code here, we have our editor. So we've talked a lot about this editor here. We've been typing stuff in here, and we've been pressing run, and it's come up here on the console. One thing we haven't looked at is this file thing on the left. So we've got main.py, that's our script, that's our Python code. And you might notice that this week there's actually another file called studydata.csv, and this is what we're going to use in our data analysis today. So I'll open that up. I can just click on it, and as you can see, this is a lot of data. So this is 1,000 records of just random people's data. So what we have is we have a first name followed by some kind of token for their gender, so F for female, M for male. We have an age, which is an integer, 19. And at the end here, we have their height. So Audrey here, who is 19, happens to be 5 foot. Well, 5 foot exactly, and 5.05 feet tall. So
worryingly, I thought that was going to be meters for a second.
yeah, like
Audrey towers above us all.
Yeah, Jason here is 5.9 meters in length. So Jason here, for example, is a male, and he's 45, and he is 5'9". So that's all this data is telling us. So on each row we have a particular person with their details. So this is some interesting data, and there's 1,000 rows here, so that's a lot of data. If we were going to analyze this by hand, it would take us quite a while. We'd have to go through 1,000 records and analyze them.
And it's worth saying that this isn't even a lot of data. I mean, Ben and I have done at least online surveys and things like that, where we've had lots more data than this. We actually created a game that lives on an arcade machine in the Isaac Newton building, and that was thousands and thousands of lines worth of data.
Yeah, so as Chris says here, I mean, 1,000 rows is quite a lot for us, but where Python becomes really useful is where we have like a huge, I'm talking massive amounts of data. So yeah, that game we made for the arcade, what we were doing is every single frame that the game renders, we were logging out data. So we had files with 100,000 lines So imagine this, about 100,000 lines long. There's no way you could sift through that. We've also done things where we've, pulled data from sources like Reddit and Twitter and so forth, and you have millions of tweets that you need to analyze. How can you do that? Well, you can do it with something like Python, because this is where it's really, really useful. So yeah, that's what we're going to look at. We're going to look at how we can analyze this data. Before I start, though, I want to mention something which might come up today, but it's something worth knowing. So do you remember when we had something like we made a variable and we said, name is Ben, and we did something like this. We did hello, we did plus name, exclamation mark or something. So this will print out hello Ben, right? So this is one way of doing it. It's called string concatenation, where adding this thing to this thing. It turns out there's another way to do it, and the reason I'm mentioning this is because if I do it accidentally in this video, you know what it is, basically. So there is another way of doing this. I'll just comment this out. Here is another way of doing it. You can do hello, right? And you put an F before the string, and you put name in here. So what this is doing is it's saying this thing here is this thing. So it's actually putting in the string. So that's another way of doing it. So if I do it this way, it's called F strings. You know what it is, basically. And it comes down to preference. I usually use things like this. Some other people use string concatenation. But if you see this format, you know what it's doing, right? It's just...
Is there a difference in optimization between those, Ben? Do you know? Is there a quicker way of doing it?
So I'm not too sure on that, actually. I think concatenation, behind the scenes, concatenation is happening with F strings anyway. F strings allow you to do some really interesting stuff with like with numbers. So if I had, if I called this number or something, and I put in 3.14152, and I said pi is this, and I put in number instead, right? If I run this, it's going to give me the whole shebang. It's going to go all the way up there. But I can say, and don't worry too much about the syntax, I can say I only want it to... Is that right? I'm doing that wrong. Yeah, I think I'm doing that wrong. It doesn't matter too much. But basically with F strings, there's a bunch of other features you can use. But behind the scenes, I'm not too sure. I don't think there is really much optimization.
So I've always quite liked just standard concatenation because I find it more readable. I think it's easy to see what's going on. But no, that's really useful to start with.
Yeah. So again, the reason I only brought this up and stuff is just like, as Chris says, it's largely down to preference. Chris prefers this style. I like this. I use it quite a lot, but when it comes to long strings, I prefer using this. So just if I do this accidentally, I just want you to know what that weird F is before the quotes. That's all. But on that note, let's stop talking about strings and let's actually get into data, as we promised. You're probably thinking, you've been promising me data analysis for 7 weeks, and now you're just talking about strings.
Longer than 7 weeks, right? We've had breaks in there as well.
Yeah. So yeah, let's get into that. So the first thing I want to do before we actually get into analyzing it is what we did last time. So we need to open up this file, okay, and we need to read the data in this. So how do we do this? Well, we looked at this last time. We do something like this. We do file equals open, and we need to tell it what file to open. So in this case, it's studydata.csv. And if you remember, I talked about this before. This means read. So we want to read the file. We're not going to write to it. We just want to read the data from this file here. So this identifies the file over here on the left. So we're just opening that, and then I'm just going to close it at the end so I don't forget. So here what we're doing is that right? Oh, I think it wants me to name it differently. Yeah, well, let's call it F, right? So F is a file, and we open it, and now it's just closing. So how can we actually read this file? So as I mentioned before, we can do for line in F. F is our file, and we can print out the line, right? So if we do this, this is going to print out all 1,000 lines of the file. So as you can see, that's a hell of a lot of data, right? That's That's 1,000 lines. And like last time, you remember me saying that this new line thing is a bit strange. If we put .rstrip here, what this is going to do is it is going to get rid of that thing. So all this .rstrip does is it makes sure that there's no extra line. So now, we've got our data, right? We're actually reading this into Python and we can do something with it. So the next step is as you can see, there are commas separating each one of these particular things. So the first thing before this comma is the name. So this lady's name is Fiona. The next thing is their gender, and then their age, and then their height. But as you can see, there's commas between each one. And if you're not familiar with this syntax, this is called a CSV, a comma separated value file. So basically, these are the columns of our road. So we have Fiona, F, and we need to extract each one of those. So that's the next question. How can we do that? Well, it turns out that there's actually a really useful feature in Python, right? If I do something like, to test this, let's do row equals Bob. Bob is male. He has, he's 53 and he's 5'8" or something, right? If we print out row, there's a really, really cool feature in Python called .split. And if I do row.split and I put in a comma, what this does is it separates this into a list for us. So a list where the first element is this, Bob, the second element is M. So this is exactly what we're looking for, right? We have took this thing here, which is just text, and we've converted it into a list where the first element is the name, the second element is and so forth, right? We've done that. So that's what we need to do for each one of these rows.
And Ben, so by doing that split,
yep.
What you're saying is that comma is you're essentially removing the comma as well, though, aren't you?
Yeah. So that's a good point. What this comma means is it means look for a comma, remove it, and then place each one of these elements in the list. So equally, right? If I wanted to split this stuff by a slash character, it's gonna print nothing really. But if I put slashes in here, if I do slash and slash,
Guns N' Roses jokes running around my head. Slash.
Yeah. So what this is saying is look for a slash, right? And between each maybe I didn't use the right character here. Maybe I should have used a colon or something.
That's even worse. Go out, look for a colon.
Oh, I don't know, $1 or something, right?
There we are.
There we go, $1. Okay. So if we use $, what this is saying is look for where $1 is in the string and basically extract each one of these. So it will become Bob and M and 53 and 5.8. So it's converting this, it's splitting it into things which are separated by this character. The official name for this is called a delimiter. So it splits up the string based on what you give it. So in this case, $. But if we use commas, which is what we have in the file, it will give us the same result. And that's what we're doing, because now we can actually start working with this data. So if we come back to our code, what we can do is we can put this thing here. We can call this formatted line or something. Let's call it formatted line. It's quite a long name, but whatever. So what we're doing here is remove all remove the extra line. Okay. And now what we need to do is do that split stuff. So split the line into separate parts by comma or by the comma character. I know that's a very lengthy explanation, but if we call this columns, for example, right, we can do formatted line dot split, and we can put in this comma here. If I'm just going to print this out, so print out the columns, what this will do is it will do what we did with Bob over here, who's 5'8" and 53. It'll do it for everybody, right? So if I print out columns and see, well, if it runs, yeah. So for each row in this thing, it's splitting it out into a separate list for us, and that's very useful. We can actually start doing something very useful with this data. So as an example, right? Let's put these separate variables. So let's do name equals columns 0. So column 0 is the first thing in this list, right? This is element 0. This is element 1. This is element 2. This is element 3. And getting your head around that is a bit confusing. Sometimes you think, that's the first element. It should be 1, but this is element 0. This is 1. This is 2, and this is 3. So 0. If we just note that down, let's just make a note. So name equals 0. What's next? Gender equals 1. Age equals 2, and height equals 3. So let's do that. Let's do gender equals columns 1. Age equals columns 2. And I'm going to change that in a minute, but don't worry too much about that. Columns 3, right? So now we've split each one of these into separate variables, right? So we can get their name, we can get their gender, we can get their age and height. One thing I haven't done here is, you see here we have, I don't know, Angela, who's female and is 44. You can see that this is a string, it's not a number. So we need to convert this into an actual number we can use. How do we do that? Well, in this case, 44 is an integer, so we can just use int. So we're converting that text into a number. Height is the same, but as you'll notice, height can have a point in it, right? It can be 5.9, it can be 6.1. So it's a floating point number. So we do the same thing, but we use float instead. And what this does is it converts, this 5.7 whatever into an actual number we can use. So just to recap,
importantly, people aren't just 5 foot or aren't just 6 foot. There's a range and scale, and that's what floats allow us to represent.
Yeah. So you could be height is one of these things where it's not a set thing. It's not like you are 5 foot, you are 6 foot, you are 5'3", you are 5'4". There's always, there's always like 5 point
shorter than me.
Yeah.
That's how that sentence ends.
Yeah. There's 5 foot 3.5 and so forth. It's a it's a floating point thing. And that's what we're doing here. So if we've now separated these into separate variables, right? So what this is doing is it's going over every line in the file. It's getting rid of that extra line character. Then what we're doing is we're splitting that into separate variables in a list. So separate, well, taking a row like this, okay, like this one, and converting it into a list like the one we see over here. And now we can do some interesting stuff. We can start putting each one of those into a variable and do stuff with that. So, for example, if I was to show everybody's height, so show height, if I was to print out height, and I was to run this, now see we get just the heights instead of everything. So this is just everybody's height, okay? And we can test if this is an actual number and not text by, I don't know, timing it by 2, because we should get, yeah, that stuff multiplied by 2. So this is definitely working, right? Now what we can do is this is called parsing the file. Is we're taking stuff which is just text, just in a text file, and we're actually we're taking that and putting it into Python. We're extracting the data from this this text, and that's what we've done, right? We've took for each one of these rows, we've looked at it, we've took away the commas like this, and we've put them in an array. So we've gone, oh, okay, that needs to go there, comma, this here, and we've placed them into a list like this, right? That's what we've done here. We're actually parsing the data. This is what this process is called. It's called parsing the data. So that's that's the reading in of this file pretty much done. Now we can actually start analyzing some of this stuff. So, for example, if I wanted to get the average height of everybody in this list, well, think about what I need to get the average. Well, the average is just the sum of all the heights. So let's start with that first. Let's sum all of these heights. So one way of doing this is you could have a sum here, right? You could have total equals 0, and you could add total. You could add to the total. You could do total equals plus equals height. And then at the end of all this, you could say total. Okay. So here, the total height is 5556.07.
But
so
Ben,
yes.
when would it ever be useful? And this is where I'm going to lead you on to the next bit. When would it ever be useful to know what the total height of a bunch of people is? Unless we were trying to figure out how many people would need to lay down to get between Lincoln and Sheffield or something.
Yeah.
That doesn't seem like that useful to do. What can we do with that information?
So with the total, we can do a bunch of different stuff. So the most obvious one is the mean. We can take the average of these heights. So this is the total height of everybody, right? But an average, as you probably know, is just the sum divided by the number of things in the thing.
Specifically, the mean average.
Yeah. So this is the mean, right? This is the mean. I don't mean the harmonic mean or anything. This is just the mean. We just take the sum of whatever we've summed up, and we divide it by the number of things. Now we know that there's 1,000 people in here. Well, because I told you there's 1,000 people in here. We could even look at the line number and say there's 1,000 people in here. To get the length of all these things, well, sorry, to do this, right, I could just print out total divided by 1,000, okay, because I know there's 1,000. So the average height is 5.5 foot, right? But what if there wasn't 1,000 people here? What if we didn't know there was 1,000 people in here? How do we get this value? There could be 500 people. There could be 700 people in here. There could be any number of people in here. So how can we do that? Well, another way to do it is, well, there's a bunch of different ways of doing this. We could have a counter, and we could add to the counter here, right? Plus equals 1, and I'm gonna touch on a different approach after this. And then at the end of this will print out how many people there are in the data set, right? If I do counter, it says 1,000. If I take away,
and we've used counters a couple of times before. We used counters in the episode on loops and iterations. So hopefully that's not something new to people.
No, all we're doing is we're making a variable called counter, and we're just adding 1 to it. Every line we go through, we're just adding 1. Now this works quite well, right? Because if I go to the top of here and I just say, yeah, just get rid of these people. Now we don't have 1,000 people. Okay, we have. Let's have a look. This counter says there's 987 people in here. So we could, instead of dividing by 1,000, we could just divide by counter instead, and that will give us our average.
And it's useful to think about counters sometimes, because at least one of the challenges I sometimes have in doing data analysis is if there is a character in there or something that is breaking something, you'll get numbers at the end that don't make sense. But sometimes by putting a counter in could just be a really useful debugging tool, just to figure out, okay, what line is this not working? Yeah,
exactly. Counters are very, very useful things, and as Chris says, they're very useful for debugging. Because if your program breaks and it breaks at iteration number 543, you can go, oh, okay, that's interesting. Let's see what's on 543 in the data set and see if it's some kind of weird thing that's breaking your program. So counters are very useful stuff. So we've done it with this counter stuff. I'm going to show you another way of doing this. So this is one way. Another way of doing this is to have an array called heights, okay, that is empty at the start. And what we do is we just add to the heights. So do you remember the dot append? And what this did was it added the data to the end of the list. What we're going to do is just append a height. So this is going to start off empty. On line 1, we're going to add the first height, and then we're going to add the second height. So at the end of this, we'll have a giant list with everybody's height in it. So let's have a look at what that looks like. So at the end of this, let's print out heights. And just to recap here, we've made an array of heights. list of heights. Okay, and it's empty at the moment. Then what we do for every line is we take the line that we're currently on. So it'll go here, well, it'll go here, and then it'll go here, and then it'll go, to the third one, and so forth. That's the wrong thing. We're taking out that extra line character, and then we're splitting that into separate things, into a list separated by the commas. Then we're extracting them into separate variables that we can actually use. And then finally, we're adding that height that we found in this row to the list of heights, right? So, and then finally at the end, we're just doing print height. So let's see what this does. Well, now we have a list with a lot of heights in it. As you can see, it starts with you can probably just about see it on your screen. It just about starts with a left square bracket, and it ends all the way over here with a right square bracket. So now we have a list with 1,000 different heights in it. So that's another way of doing it, because now what we can do is we can actually just sum the heights down here. So the same thing, we could have a total, and we could do for height in heights, this giant list of heights. So go through every height, add to the total. So plus equals height, okay, and then print the total. If I run this, we get the same total that we did before. It's just done in a different way. What we've done is we took all the data, added it to an array, the bits we want, and then down here, what we've done is we've gone through each height that we found, and we're just adding to the total. So this is another way of doing it. And you might think, oh, okay, that's great, Ben, but how do you now divide this number by the amount of things in it? Well, there's another way of doing that. So if I do len of heights, let's see what this gives us. This gives us 1,000. So len tells you how many things are actually in that particular
So
list.
just to clarify, len means the length of the array.
Yeah.
Or the length of the list of the object, or
yeah. So len is short for length. So it just, if you have 5 items in a list, len will give you 5. If you have 1,000, it will give you 1,000. So the first way how we did it was we read in and we added to a total as we were reading in the file. The second way, what we're doing is we're reading in the file into an array, a list, and then after that, we're doing some analysis on it. And this is what we're going to use for the rest of the examples. So yeah, that's all we're doing here. We have a total, and we're just adding to the total. So if we wanted the mean of this, we could do total divided by len of heights, and then we could print out the mean. So let's have a look at that. What do we see? We see the average height of all these people is 5.55, which is what we had before. So that's great. Now, a part of you might think, oh, okay, this is quite interesting. We could separate this out into functions, So you could have a get mean of a kind of data, right? And you could take all this code and just put it into you could essentially take all the stuff here, replace that with data, now you have a function that will do this for anything. So now you can just do get mean of the heights, right? And this will give you the same answer. Now you might think that's great. Wouldn't there be? It would be great if there was a library that comes with Python that has loads of these, like get mean, get median, get the standard deviation, get all kind of, the variance. You could look at any kind of statistic that you could use on this data. Wouldn't it be great if there was a library, some code that somebody else has made that we can just use straight off the bat? Well, it turns out there is, and I'll talk about that in a minute. Before that, though, another statistic that I want to talk about is the median, right? So we've done the mean here. We have heights. Well, the median is just the middle value of a sorted list, right? So if we have heights, we would need to sort that from lowest to highest and then take the middle of that. So the way we can do this is we can say middle, let's call this middle, is just the len of heights divided by 2. Now this we need to convert into an integer, so we just put int around it. And then what we can do is do sorted heights equals sorted of heights. So this first one, what this is saying is it's saying if, our list is 1,000 items, it's going to give us 500. So that's all this is doing, is it's just taking the length of heights, which is going to be 1,000. It's going to divide that by 2, which is 500. And it's going to turn it into an integer for us. So that's what this is doing, is it's getting the middle index. Sorted heights, what this is doing is sort the heights lowest to highest. Lowest to highest. So, the first element in heights will be, I don't know, somebody who's maybe 4 foot or something. And then the highest will be somebody who's maybe, I don't know, 7 foot or something. I don't know. But that's what this is doing, is it's sorting the heights for us. So if I print out sorted heights, let's just see if it is actually printing out that sorted heights for us. So yeah, as you can see, there's 4.9 here, and it slowly gets. I think I just need to clear this console. Let's clear that console. Let's run it again. So down the bottom we've got 6.3. So someone who's 6'3" is the highest, and then all the way up here we have 4.9. I think. Yeah, I think that's the case. So that appears to be working. All we need to do is get the median is to just do this, right? So sorted heights middle, get the median. That's how we can compute the median. So if we print that out, we can put something like the median is, and we can put median of all that, and let's have a look. I don't know why, but it appears to have. Oh yeah, it just died on me. I have no idea what it's talking about. Yeah, okay. It seems like we're back to where we were. I don't know what that was all about. So let's try this out. Let's see what it gives us.
Sometimes there's that if you've got intermittent internet.
Yeah, I've had this sometimes on replay. It just says, "Oh, I can't connect," and yeah, I don't know. It's all good now. So it says the median is 5.58. So we can get statistics this way, right? We've got all our data. We're going through it, and we're doing some very basic analysis on this. So the next thing I want to talk about is some inbuilt functions in Python to do this for us. You can see that we made a function for getting the mean. We could make one for getting the median as well. But we've done all this stuff manually, right? Is there a way we can speed this up? Is there some kind of library out there that does this for us? So I'm going to talk about that now. So up at the top, I'm just going to import statistics. And as the name suggests, what this is saying import the library called statistics. And as you can guess, statistics has a bunch of different stuff we can use in it. So just as an example, I'm going to comment all this out. Okay. And let's just
we've used the analogy of a toolkit before. Like when you use import, it's like adding an extra tool into your toolkit.
Yeah, that's a good analogy. So yeah, that's you can kind of think of import like that. Is all of this is our code, but if we want some extra stuff, if we want another tool that we can use in our code, there's something somebody's made years ago called statistics, and what this does is it has a bunch of little functions in there for doing stuff like getting the mean, getting the mode, and so forth. So let's have a look at that. So we have our heights. So at this point we have our heights, so let's print it out again. Look at this massive array. That's a giant array of heights. Well, what we can do is there's a couple of functions in statistics that can do this stuff for us. So if we wanted to get the mean, do you remember before we had to get the sum and so forth? The first one is sum. Now, this isn't actually part of the statistics module. This just sums it regardless. So if we put sum and then put in a list, it's going to sum all of those. So this is the as you can see, 5,506. This is exactly what we had for 5,556. So this is just doing the stuff we did here, for height in height, total plus height. It just does it for us. So this is the sum. So if I do the sum is, and then all of this, right? So we get the sum is this, and we can do something like this again. Let's put in the average. Well, the mean is, and this is where we start to use statistics. So I'm going to put in mean here just for readability. Let's make a variable called mean, and it is just statistics.mean, and we pass in heights. Okay, and I think that's the right syntax. So let's run that, and as you can see, it gets the mean for us, 5.56. So instead of doing all this stuff, we can just use this one that somebody else has made, and it's a lot sort of quicker to build stuff, and it's a lot easier to read. So we can just use something like this. There are other things that we can use. So we can get the median, and again, we can use the trusty old statistic module to just say, hey, give me the median of these heights, please. Okay. We can do the same thing. We can just say the median is, and then put in our variable median. And as you can see, look, we've got a sum, we've got a mean, we've got a median, and we've done this in 2 lines of code and 3 lines of printing, really. So we've got some. The statistics module is a really, really useful feature. There is also a whole bunch of different stuff. So, for example, the mode, you can do statistics.mode of the heights, and this will get the mode. There's also the standard deviation. So there's statistics. I think it's stddev of heights, right? So I can do this same thing again. I can say the mode is mode, and the standard deviation is stdev, right? So if I run this, you can get all of this information: the sum, the mean, the median, the mode, and so forth. So we've got, from this little thing we've import statistics, there's a bunch of functions in there, like statistics.mean, statistics.median, statistics.mode. If the dot is confusing you, don't worry too much about that syntax. All this is saying is it's saying get the mean function from the statistics package, get the median function from the statistics package, and that's all it's saying. So yeah, there's just some useful functions we can use. We can have, now we have a basic breakdown of these heights. We can start, answering some questions with this. We know that the average height is about 5.5 foot. We can also do max and stuff here. So there are some other functions for min and max, and we can do that kind of stuff, but I won't get into that. But yeah, that's quite an interesting tool. I suppose another interesting question to ask, right, is, sure, yeah, we've done some sort of descriptive statistics on this data, but wouldn't it be cool if we could actually see if there was some kind of effect in our data? So could we test, for example, if we wanted to ask this question here? So I'll just put a line so we know where we are. What if we wanted to say, is are male or female participants, are male participants shorter or taller than female ones, or something? So essentially go through this and look at the average height for male and look at the average height for female, and test whether or not one group is taller or shorter than the other. So it's essentially a kind of similar to what we were doing here. We were getting the mean of everybody. We were going through all 1,000 rows and getting the mean of all of them. But now what we want to do is we want to get the mean of one group of those. So let's look at this. We just need to modify our code a bit. So I'll keep this in here. But let's make 2 other arrays. Male heights. And you can probably tell what I'm going to do here. There's 2 lists now, male heights and female heights. And I know a lot of people who are watching and know Python will probably be screaming at the screen going, oh, why don't you use a dictionary? Why don't you use a class for this kind of stuff? But the idea is that we're just using stuff from previous weeks in this. So we have male heights and we have female heights, and we can do this kind of thing. But look, we have this gender variable here, right? And it tells us what gender the person is. So we can say if their gender is equal to, and let's have a look here, M or F, right? You could have other options in there, but for this data set, it's just M or F. So if gender is equal to F, then add to the female heights. Right? So if their gender is F, in this case, add to the female heights. Else if gender is equal to M and male heights, add to that. So now what we're doing is we're adding conditionally to two separate arrays. We have male and we have female. And in this case, these are our two treatment groups. These are our two groups that we want to evaluate against. So we have group A and group B. In this case, you could call this group A or something. But in this case, we're just adding male heights. Well, if the gender is male, then we add to the male heights. If it's female, we add to the female heights. So if female, add to the female heights. So that's all we're doing. And this stuff here is about the whole data set, not just male and female. But now what we can do is we can do the same thing. So we can say average female height equals, and we can use our stuff here, statistics.mean. And instead of height, we want to just look at the female heights. So let's put in female heights and do the same. But let's do it for male. So let's just put in male there instead. Now let's print these out. So we can do something like male. We can put in something like this. We can do average male height, and we can do the same for female. And let's put in the female height there as well. So what we're doing is, just to again recap this, we have before we were looking at the entire data set, and we were adding, it still is adding each height to a list called height. Heights. What we're doing now is we're adding, if their gender is F, add it to a list called female heights, which is up here. And if their gender is M, add it to a list called male heights, which is up here. So we're adding all the male heights to a list and all the female heights to another, right? And now what we're doing down here is we're finding the average female height and the average male height. So now we can print these out. So let's see what we get. Yeah, I haven't formatted it very well, but as you can see, it says male height is 5.9, right? So that's 5'9". That's the average height for male, and the average female height is 5'2". So we can look at this and kind of conclude that there might be a fairly big difference between these two. But how can we actually check? There's we could run a statistical test to test if these two groups are different. We can eyeball it and say, hey, look, there's two completely different means here, and we have quite high power because there's 1,000 rows. But if we wanted to run a statistical test, then you can. Now you remember we had statistics here. Well, there is another package that is widely used, and it's called Scipy. So let me think Scipy. Yeah. So this, right, what we're saying is import stats. So scipy.stats. This is a really, really popular scientific library for Python. So it has everything from statistical tests to interpolation, all kinds of different stuff. You can do integrals, fast Fourier transforms, all kind of stuff in this library. So if you're interested in that kind of stuff, definitely check this out. This is a really, really useful library. And I just want to show you how to do a statistical test. So for example, if we wanted to, if we didn't know this day was normal, and we wanted to do a non-parametric Mann-Whitney U test, we could do something like stats.Mann-Whitney U, and we could put in our two groups. We could put in female heights, in male heights, and this would return us some kind of result. So we could put in our U and P. Now this syntax, I don't really want to get into what this syntax means. It's a really interesting one.
It's worth just explaining what it's doing, I think.
Okay. So what's happening is, do you remember we said before that Python it returns things, right? What this is doing, you can kind of think of this as returning two things. It's returning something called a tuple or tuple. Yeah. What it's doing is it's returning one thing, which is the tuple, and that tuple has it has two things in it. It has this and it has that. But basically, you can think of this as returning two things. It's returning as a U statistic and a P value. So let's just print that out. And I'm not sure if this will run because I might have got the syntax wrong on the import. But let's see. Yeah, I've got this wrong. So I think it's from some import stats. Try that. Let's see. Yeah, okay. That's it then. So what this means is saying from the package Scipy or Scipy, whatever you want to call it, import the module called stat. So basically, a package like Scipy or Scipy, whatever, has many different packages underneath it.
I think it's only me who calls it Scipy.
Okay. But yeah, this is saying import the statistics module from this. So now we can use stats.manWhitneyU, and we can do something like, you can see this is a very low number. So we can say if P is less than alpha, we could make something called alpha. In this case, I'm just going to say if it's this, then we can say there's a significant difference. Otherwise, there's no significant difference. I'm printing out the p-value. So what this is saying, what we've done here is we have added all the male heights into one list. We've added all the female heights into another list. We've done some statistics on the data set as a whole. So we've done things like the mean, the median, the mode, and the standard deviation, all this kind of stuff. And we've just printed this out. What we've also done is like I said, we added all the female heights and all the male heights to a separate array, and we've just ran a ManWhitneyU test on it. So I think this is, yeah, okay. So it says there's a significant difference. So this means, according to this test, that there is a big difference between these two groups. So yes, in this case, it seems that male participants were taller than female participants, and we have a non-parametric test to back us up. But there's other tests. If it was parametric, we can use let me see if I can remember this. I think it's Ttest ind. So this is a student's Ttest, independent samples. So we could do this test as well instead, if we wanted to use that one instead. Let's see what this gives us. It says there is a significant difference. And interesting, it gives us a p-value of 0. But it's basically saying that there's
which
barely
is the wrong test to use. So
yeah. But yeah, there's all kinds of different tests. You can have chi-squared tests. There's ANOVAs, all kind of stuff in this library. So it's a very useful thing, and that's why I wanted to introduce it. Another thing that might be interesting, another question that you might want to ask is, what is the most frequent name in this data set? So, if we go through this, we do have repetition. So we have, let's have a look. Well, there is repetition. I know this for a fact. But yeah, so there was a Joshua earlier. So there's a Joshua here, and there is a Joshua all the way up here as well. So there is repetition in this. And the question is, what's the most common name in this data set? So how can we figure that out? Well, again, another way to do this is to we have heights, we have male heights, we have female heights. You can probably guess that the next thing we're going to do is have another array called names. And again, most people who know Python and are watching this are probably like, oh, why aren't you using the dictionary? Oh, all this kind of stuff. But just for the purpose of this, we're just going to use lists. So we have a list called names. It's empty at the moment.
So actually, a list is a perfectly reasonable way of doing what we're doing. Because there might be other things that we want to do with this data as well that an array lists itself into, and the other side as well. This is a an introduction to getting to. I mean, we've gone from no coding at all in episode 1, all the way through to relatively advanced data analytics. So it's there is an advantage sometimes to using what you know, right? So there's dictionaries, there's all kinds of data structures, and maybe if there is another season of the Ben and Chris show, we'll do a whole whole episode on data structures, right? But arrays aren't the worst way of doing these things.
No, I think I use lists and stuff a lot anyway, just because one thing that Chris had was that you have a lot of control over your code. If it's stored in a kind of primitive way, like just using a list, it's a lot more easy to understand, and it's also you have sort of more control over it. And this is just the way I think. Really, I think of things in terms of lists and stuff. But anyway, we have a list called names, and you can probably guess what we're going to do now. We have append heights, so I should change this to append to heights. Let's make another one. Let's call it append to names. So we're going to do the same thing. We're just going to add the name of this person that we're going through. So remember, this is going through each line, and then it's splitting it out. We're getting their name, we're getting their gender, we're getting their age, we're getting their height. And then, we're saying if they're female, add to the female heights. If they're male, add to the male heights. And then at the end, add their height to the list of heights and add their name to the list of names. So, if I was to show what's in names, so I'll get rid of this. Let's just print out names. So this is going to be a very big data structure, right? With just everybody's name in it all the way down here. That's what we have. And what we're trying to do is ask, what is the most frequent way of what's the most frequent name in this data set? So there's a bunch of different ways of doing this. I mean, there's no one true solution to doing this. You could go through each name in the list of names and then count how many times it's in the list of names. So basically, if you're trying to count the frequency of Jason here, you'd go through each one of these and add one, and then basically find the max of all those. So you could do it that way. So if we were searching for Jason, for example, we could have total equals 0, and we could say for name in names, if name is equal to search, in this case it's Jason, we could just do total plus equals 1, and then at the end, let's just print out the total. So this will tell us how many times Jason has appeared in the data set. So let's just run that. Let's see what happens if it gives us an answer. I don't know why, but replay is being really slow today. To be fair, it's probably the fact that we're telling it to read in 1,000 things. I think I've missed a print statement up here somewhere. Let's have a look. No, I think I'm good. Yeah, so it says that Jason has appeared 8 times. So what you do is you do this for every name you encounter, and then sort those, right, and then figure out who has the most common name. Another way to do this, right? There's a couple of different ways of doing this. I won't get into the full solution in the sake of time, but let's have a look at that statistics.mode thing that we had. So mode will give us the most frequent value in something. So if we do statistics.mode of name, this is going to give us the most frequent name. Well, sorry, put names. There we go. So yeah, the most frequent name in this case is Joshua by chance. Now, somebody who knows about statistics.mode will say, oh, actually, multimode. So there might be, in some cases, there might be 11 Joshuas, and there might also be 11, I don't know, Franks or something, right? So what if that's the case? Well, there might be two most frequent names. So that's what multimode does, is it gives us if there's more than one frequent thing, it will tell us both of them, or however many there are. So let me see what this is doing. So yeah, in this case, we've got Joshua and Luke are the most frequent names in this data set. So they'll both have, I don't know, 11 occurrences or something.
And hopefully everyone can see how you can start combining this stuff, right? Because you could then use this into your next line to get the print the average height of the most common named person. Is there a correlation between a common name and being tall, for example?
Yeah, exactly, right. We can. This
Never
is
met a short Chris. So.
Yeah, I mean that's an interesting question, right? I mean, is somebody's name correlated to their height? And you could use Python to do this, right? You could get everybody's height whose name is, I don't know, Carol or something, and then basically do some correlation analysis on this. Just before we get onto this stuff, I will just talk quickly about another very useful thing. So here we've got the most common name, right? Joshua and Luke. They're joint first in the most common name in this data set. But is there a way that we could list maybe the 5 top, like the 5 most common things in a data set, or the 20 most common names in this data set? Is there a way of doing that? Well, yes, and you could program it yourself, but there is a nice little package called collections that does this for us. So we can say from the collections package, import the function called counter. And I could just say use collections.counter, but all this is saying is from the collections package, import this counter thing. And you might think, what is counter? It sounds quite strange. We've got a variable called counter up here. Well, we did. It's not that kind of counter. What counter does is it does exactly what we were talking about just then. So if I do, for example, I call this names counter, and counter of the, let's put in names. So what this is doing is it's going to make a new counter for this names thing. And then what we're going to do is we're going to print out, this is where it's really useful. If we do names counter dot most common, okay, and we just put in a number here. If we want the 5 most common names, we put in 5. If we want the 10 most common names, we do 10. If we want the 20 most common names, we put in 20. And what this will do is it should print out the frequency of these names for us. I have got that wrong. Yes, that's my bad. There we go. Let's run that. So yeah, it's saying that Joshua and Luke were the joint first, and then Stephen came in with 12 occurrences, then John, then Emma, Joanne. So this is listing the 20 most common names in this data set. This is a very, very, very useful tool. And I would definitely recommend having a play with this because it's a very useful tool. One of the last things I want to talk about is, again, some of the other stuff.
Actually, just while we're on this, Ben. So, like I said, there's all these really useful functions to do this kind of stuff for you. It's actually a really good exercise and actually one of the first kind of programming assessments I ever wrote for students was to do exactly that, to write a script to, write an algorithm to pull out most common occurrences. And this is where we kind of get into the algorithm design side. It's worth kind of trying to decompile these problems and think of useful solutions around them. So, like I say, although you've got all these functions available, it is worth just trying to think of it as a problem to solve as well.
Yeah, definitely. I mean, this is a really interesting one because at first, right, to find the most common name in a data set is easy, right? I mean, it's pretty much find the most frequent thing, keep doing it for every name, and find the maximum of that. But if you didn't want that, you wanted a list of the 5 most common names, it's actually quite a tricky problem. You have to stop and think, actually, how would I do that? And like Chris says, that's a really interesting and a really good exercise to learn how to program it.
And there's often there's a way of doing it, and there's a fast way of doing it as well. And the way that we've been talking, and it's a good way to think about it, about going through everyone and, then going the next one, then doing the next one. But it's slow. So how do you speed up that process? How do you only check things once, for example? It's these are really interesting problems to just think about and try and solve, even if just on a piece of paper.
Yeah, and there's a whole art to it as well, because one of the biggest things that gets people is this idea of, sure, yeah, I mean, you've followed for all these episodes we've done, but something like this is a really tricky problem, and if you can't get your head around how you'd solve this, don't worry, because it's algorithm design and programming skills are almost completely they're quite different. You've got to think about things computationally, breaking down a really complex problem into steps like this. How would we solve this problem? Well, it's quite a tricky problem. Thinking about that and writing down how you would design this algorithm is a very, very good exercise for learning how to program and learning problem solving skills as well. So yeah, anyway, probably the last thing I want to look at is just some basic correlation analysis. So we have this Scipy import stat stuff. So the stat stuff doesn't just come with bog standard Ttest and chi-square tests. It also comes with a whole range of other statistical stuff. So for example, correlation analysis. If we wanted to correlate whether age, if age is correlated to height, so if as age increases, their height increases, or vice versa and so forth, is there a positive or a negative correlation there in that data? We can do that quite easily with Scipy. So what we do is we do stats dot we can use a Pearson's R, or we can use a Spearman R. There's also Kendall, Tau, and all those kind of stuff. There's other things like the Kolmogorov, Gorov, Smirnov test, and all this kind of stuff. But here we'll just use a Spearman's R. So what we do is we can put in our, if we wanted to correlate age against height, well, we'd put in ages and heights. This is going to error because there's no such thing as ages, or there shouldn't be. So again, we can make another array called ages, and we could add to this thing. We could do ages dot append and put in the age for this person. So append the ages, right? And then finally down the bottom, we now have a list of ages. We can do this correlation test and say, are ages correlated to height? So we can do coefficient and p. So similar to the way this is working, this gives us this test. Well, not this test. The the Mann-Whitney U will give us a u value, and it'll give us a p value, right? This will give us a coefficient, a correlation coefficient, and a p value. So we can print this out, and we can say p.
Ben, just as a thought,
yes.
Where would somebody find all the tests that they can do in this package? So I know, you get your statistics book and you're trying to figure out the right test for your data, and got all the standard, your ANOVAs, your Mann-Whitney, so on. And then there's those weird tests on page 187 of the Great Book of Statistics. Where can we find the listings for that so we know what code to put into that?
So that is a very good question, because so far you've probably just gone, oh right, it's got this, oh right, it's got this. But if you want to have a look at everything Scipy has to offer, I'll just quickly go into a new tab here and go here. So you can go to this link here, which I'll probably put in the which will probably appear.
Drop
here
it in the chat,
soon.
Ben.
Yes.
Oh yeah, there we are.
Yeah. So here is a good index.
Sent it to the private chat, so I'll post it up in the comments for you.
Okay, sorry. My bad. So this is Scipy, the Scipy package that we were looking at, and maybe I'll zoom in here so you can see a bit better. There we go. So there's all kinds of stuff that this has. As you can see, there's not just stats. It has things for. So here's the one we're looking at: statistics. There is integration, optimization, interpolation. all kinds of different stuff that you can use, but we are using scipy.stats. So if we click here, this should tell us all the things that we can get out of this statistics module. So we've got, it tells you how to use it. So from scipy import stats, from scipy.stats import norm, all this kind of stuff. And there's a bunch of code here. And there should be a list somewhere of all the stuff it can do. I think it might be up the top, actually. I might have got this wrong.
For example, I mean, can we do the Concatenation test?
Yeah. I think I might have got, okay, so here we've got the Scipy reference guide, and we can look down here and see all the tests it does. So if we were looking for the Concatenation test, we could search this list for that particular test. Here we have some distribution stuff, so we have things to give us gamma distributions and so forth. We've got multivariate distributions and stuff, and we also have discrete distributions, but probably the ones you'd use a fair bit are things like this. So you can find the harmonic mean and the geometric mean. There's all kinds of stuff in here. There's things like you can start doing things like cumulative frequency histograms, so you can bin a particular range of values into separate things. There's, like what we were looking at, there's things like this, the correlation function. So we can do Pearson's R, we can use Spearman R, all this kind of stuff. And that's what we're looking at. And here are statistical tests, right? So we've got all kinds here. We've got the Kolmogorov, Goranov, Smirnov test of normality and all that kind of stuff. We've got the Mann-Whitney U. We've got the Wilcoxon science rank test, the Kruskal-Wallis H test, all kinds of different stuff here. And we can also do kurtosis tests and all kinds of stuff. So there's a hell of a lot of functions that you can use in this. And as you can probably see just down here, there is so much stuff here. And it's, if you're interested in this stuff, have a look at this. It might be quite useful. But there are other stuff here as well. So there are things like integration and interpolation. So I've used this one, interpolation, quite a lot. It is for spline interpolation. So you can, interpolate splines and so forth. But I digress. Anyway, to just get back to this, if I print out this P, it should give us, it says 0.5. So that is more than 0.05. So chances are age is not correlated to height in this case. But that's just an example of what we can use. As you saw, there is tons and tons of these tests available in Scipy, which makes it a very popular library. So there's all kinds of stuff you can do with this.
Brilliant. Well, I think next week, we've talked about doing some graphs and charts.
Yeah.
So, okay, now we can do our basic statistical test. We'll probably keep this kind of participant database as our example, and show how you can graph some of this data out. But hopefully this is shown, you can do some really quick, rough statistics, but also, quite functional stuff through Python. Next week, we're going to go into how you can actually then present that in a way that we can download and access it. And the really nice thing about Python is it's free. So, and there's a lot of kind of plotting libraries and a lot of stats things that we might want to do in Python. That's absolutely free. It's all there. It's all available. And as Ben's demonstrated today, it's not that tricky to do. If you follow for those reference libraries, follow for those descriptions, you can do some relatively cool bits of statistical analysis. On that note, I think we'll call it a night. Thank you for tuning in, and we'll see you soon.